Hello guys, welcome back to my YouTube channel. I am Suprita Kar, currently pursuing BE in Sri Venkateswara College of Engineering, Bangalore, in the branch of Artificial Intelligence. Currently I am pursuing in second semester and my USN is 1VE 23CA045 and today's course is Introduction to Civil Engineering and the course code is BESCK204A. And today here we are to discuss about problems based on centroid. Before that, let us get into the topic what is a centroid. The centroid is a fundamental concept in a civil engineering, playing a crucial role in a structural analysis and a design. This introductory section will provide an overview of what the centroid is, its importance in civil engineering, and the methods for calculating it for a various shapes and structures. Let us see the definition of a centroid. The centroid is the point at which the entire weight or a mass of an object is concentrated. It is the geometric center of an object where the object's shape and size are taken into consideration. In civil engineering, the centroid is a key reference point used in a calculations and analysis as it helps determine the distribution of forces and stresses within a structure. Calculating the centroid of a simple shapes. Rectangular shapes. For a simple geometric shapes like rectangle, the centroid can be easily calculated by finding the midpoint of the shape along both the x and y axis. This provides the precise location of the centroid within the object. The second one is the triangular shapes. Determining the centroid of a triangle involves finding the intersection of the three medians, which are lines connecting each vertex to the midpoint of the opposite side. This point represents the triangle centroid. In this problem, we are going to discuss only two shapes, that is a rectangular and triangular. So I have discussed only two shapes. How to calculate the centroid? Let us get into the steps. Identify the individual simple shapes that make up the composite shape. That is, identify the given reference axis. If the reference axis is not given, consider the bottom most part of the figure as a x-axis and the leftmost part of the figure as a y-axis. And next calculate the symmetry of the figure. If symmetry is about a vertical axis, x total is equals to total width of the figure divided by 2. Similarly, figure is a symmetrical about a horizontal axis, then y is equals to total depth of the figure divided by 2. If the figure is asymmetrical, then divide the composite section into a known geometrical figures, that is, calculate the centroid of each composite individual shape. Next, determine the centroid of the geometrical figure axis of the following table. Later then, determine the total area of the mass of the composite shape, that is, the centroid of the composite section is given by x bar is equals to sigma ax divided by sigma a and y bar is equals to summation of ay divided by summation of a. Use the weighted average formula to find the overall centroid location. Let us see the one example. Determine the centroid of the figure given below, and this is the figure shows four components. Here there are two triangles and two rectangles divided into an composite shapes like rectangle and triangle. Let us see how to do this problem. Here, make a table such as component area x-axis, that is a distance of x-axis with respect to y-axis and a y with respect to x-axis, and ax, that is a multiplication of area and x, and ay, that is a multiplication of again area and y. Let us take this is the first triangle, that is a triangle 1. The area of the triangle will be half into base into height, and here half into the base will be a 6 centimeter, that is the total, and the depth is equals to 2 meter, that is 6. Next, the distance of a x with respect to y-axis, that is 2 by 3 into 2 is equals to 1.33. Next, the y-axis, that is the distance with respect to x-axis, that is 1 by 3 into 6. Here we get cancels 3 ones and 3 twos, and the y is equals to 2. And ax is equals to, if we multiply the area into x, the answer will be 7.98, and a with a y, the answer will be 12. Here completes the triangle one. And the second one, let's take this a rectangle, that is as a component 2, and the area of the rectangle will be length into breadth. In here we'll take in breadth into depth, that is a breadth will is 2 meter as shown in the figure, and 7.5 is the depth. Here we should calculate the depth of the three components, that is 1 plus 5 plus 1.5. Here gives the 7.5, and the total area will be 15. And the x, calculating the centroid distance of x with respect to y-axis. Here the triangle is little bit far away from the y-axis, so the distance from the rectangle from the y-axis to the rectangle is 2, so we should add 2, and the x value that is uh, d by 2, so 2 by 2 get cancels and 1, here comes the 1, and 1 plus 2 is equals to 3. Let's get for y-axis. Here this is an b by 2, and b is 7.5 divided by 2, this gives 3.75, and ax 1.5 into 3 gives us a 45, and 3 into 3.75 gives 56.25. Here completes the second component. Let us take a third component. This is a little bit far away from an x-axis and even from y-axis too. Let us calculate there. As triangle 1 replicates, the area of a triangle is half into base into height. Here half into base, here comes an 4 meter as shown in the figure, and height is a 5 meter. You should consider only rectangular as in. So after calculating this, the answer of the area is 10, and here x. The x bar value is b by 3, so 4 by 3 plus 4, because it is far little bit away from an x-axis. So we should add a 1, and here this is a far away from an y-axis, and here we should add 2 plus 2, that is 4. So that is why 4 plus 1 by 3 into 4. Here comes the x value 5.33, and y-axis, that is by d by 3 into 5 is equals to, here y1 means it is little bit far away from an x-axis, but the distance between the x-axis to the triangle is 1 meter, so we should add 1, and the answer is 2.67. Calculate as ax and ay, and this completes the component 3. And rectangular 4, this is near to the x-axis but far away from an y-axis, so as area of an rectangle is 5 into 1 b into d, that is equals to 5, and x component is d by 2, d is 5 and 2 plus 4, because it is the distance from y-axis to this fourth rectangular is 4 meter, so we should add 4, that is equals to 6.5. And y-axis 1 by 2 is equals to 0.5 and AX is equals to 32.5 and 2.5. Here, this completes the calculating of a centroid of each component. Now, summation of A, we should add the four values of these sum area and similarly as AX and AY. And the last step is X bar and Y bar, calculating the X bar and Y bar. To calculate the X bar, the formula is summation of AX divided by summation of A, that is area, that is 138.81 divided by 36. This gives an answer of 3.856 meters. And Y bar is summation of AY divided by summation of A, that is 97.42 divided by 36. That gives an answer 2.706. This completes the problem of the centroid. Let's give a conclusion. Importance in civil engineering. Accurately determining the centroid is a crucial for structural analysis, load distribution, moment calculation, and stress analysis, enabling engineers to design safe and efficient structures. Thank you for listening. I hope you liked the video.